So we're live right now.
I think so. Is there somebody like Kenny? Is he going to be saying opening words or anything?
I'm not sure, but if anyone's listening, welcome to Mixed 2008 Robotics Competition. Right now, everybody's getting set. We're setting up the robots, making sure everybody has everything ready to go. We're adjusting for the lights, and it looks like it's going to be pretty exciting. The home team here.
Do you know who Turing is?
Turing?
The robot Turing?
No, I do not know who the robot Turing is.
Okay. Are you part of this competition?
I am announcing this competition.
Awesome.
You are live right now, my friend.
Awesome. So, do you know the robot names or anything like that at this time?
I do not know any of the robot names. I'm just calling it as I see it, actually.
Okay. Thanks for your time. I'll let you get back to your announcement.
Thank you very much. Now we have the two UWL teams here. They've been working long into the night. I know these guys. They've been working long hours, and they've really been in the lab for probably the better part of these last 24 hours, making sure everything's ready. They're rushing here even at the last minute, trying to get everything set up, everything working. These lights, I hear, have been really having some trouble with these robots, making sure that their sensors are calibrated and everything, but I think that they should be able to figure it out, and hopefully it'll be a good competition. Hopefully we'll be getting started here in just a few minutes.
The organizers?
The organizers over there seem to be setting a few things up before we get going, but we have to thank Kenny Hunt, the rest of the mixed team, Becky Yoshizumi, UWL for hosting us here today, and everybody else who's been...
I want to get you on camera if that's okay.
Sure.
Just briefly, get you in the corner.
Hey, this is, again, Mixed 2008. Welcome all the viewers on cable TV, and if you're listening in over podcast, we are live here at Mixed 2008, and we're getting set for the robotics competition here today. Everybody is looking excited. We have a lot larger audience than I thought we would. It's really exciting. I hope that all 16 teams, big turnout, really have a fun, exciting time here. Each of the robots, some very widely in their design. You know, we have a lot of the, closed circuit, get the ball, pick up the ball, drop it in as much as you can. We have the shooting robots. The competition is, as you probably can tell, is a basketball competition. Each of the robots, we have 4 balls. The objective is to get the ball in through the Nerf hoop. The robots can either shoot the ball from beyond this black semicircle here for 2 points, or if they do it from within the circle and dunk it, they get a single point. This is, of course, leads to a number of different designs and everything. If you have a robot that can only shoot 1 ball every 2 seconds, you'll get just as many points as a robot that can dunk every 1 second. I mean, there's a lot of different strategies that you can use, and hopefully we'll see a number of different ones here today. We'll have 2 concurrent competitions running at once. We'll try to pick the most exciting one, give you guys the best experience here. As you can see, we have a lot of teams here, namely UWL, University of Wisconsin La Crosse, people from North Dakota, people from St. John's University, Scholastica, a whole lot of people here today. It's going to be quite a competition. Looks like we're getting set up here, and hopefully in just a few minutes we might have some action for you. Looks like we're positioning all the balls in their correct locations so the robots will be able to find them when we turn them loose. It's a semi-autonomous competition, which means that once you set the robots free, they have to do all the picking up and shooting of the balls themselves. But if they return to beyond this red line, the robots will be able to be reset by their teams, and they'll be able to be positioned directly so that they're in line with the ball, they're in line with the hoop, and then they can tinker with the robots as much as possible. But once they let them go, they have to play the game by themselves. They're not allowed to be tinkered with while they're on the game floor.
So now we're ready to go when the judges get in place. Turing Machine and Rangers, you're going to be on court number 1, which is the farther away from me. Saints, Control Alt Delete, you're going to be on the one closer to me.
Looks like we're getting our first matchups here, Saints against Control Delete. And the Turing Machine should be set up here to go in just a few minutes.
Yeah, go ahead. Do we have somebody that wants to help keep score? It's a pretty easy job. Yeah, unbiased. No, you just have to. No, but you have to do it more than once.
Again, if you're just tuning in, this is the Mixed 2008 Robotics Competition. We're getting ready to start here today. We have 16 robotics teams from around the Midwest, all getting together here today to do this basketball competition. They've been programming the robots, getting them ready for the last few months. And it looks like we just had the opening coin toss here on this far court, getting ready to set up these two machines to get started.
After about 5 seconds, when they start moving, you want to.
So how this will work is you're going to go, if you score 2 points, I will show 2 or 1, and then the scorer there will try to update 2 or 1 and say here. And I got to make sure, hopefully this first time will go okay.
So what's your robot you got here? Does she have a name?
Yeah, it's Turing Machine.
Turing Machine. Ah, I've heard about this machine. Now, how long have you guys been working on this?
Well, I don't know, a couple months. Probably. I don't know exactly.
Where'd you get?
Pretty good though. I like how you made it man-made.
Yeah, you really used a lot of different parts. I mean, generally we see a lot of Lego and other type creations. What gave you the idea to have this kind of design?
It just seemed like the natural thing to do. It dump, like kind of, it'll grab the ball and put it in and drop it back in the basket. So it just.
So now it can do that over and over again, hopefully for the whole competition, right?
Yeah.
So now, if you're going in close like that, how in the given time period, how many points do you think you can get with this robot?
I don't know. I'm hoping some. I think maybe 10, but that's if it doesn't go on course.
That's a pretty good design. Now you have you have 4 balls out there. Are you only going to be using this one, or are you going to be making any attempts to?
Hoping I could just hang on to the one.
Just hang on to the one. All right. I know some machines have decided that they're going to, throw a few balls around there to try to throw out those other robots, see if they can't get an advantage. All right. Looks like we're just about ready to get started here.
No, they're not robot control. No control. The only thing is that they can go back to their start.
All right. Now, who do we have in this corner?
Rangers.
Rangers. All right. Great looking robot there. A little more conventional design. You got the connects going. You got the servos and everything ready to, I would imagine, shoot the ball all the way across the court there.
Yeah, we're going 2-pointers.
2-pointers. Now, that's an interesting strategy. Do you think that you can effectively make those 2-point shots? And
Yeah, worst case, you get a 1-point shot.
Now, how long have you guys been working on this robot? Has it been a really big project for you guys over the last few months?
Yeah, since the first semester.
First semester, okay. So now this robot is definitely a shooting machine. You got the longer arm there, and I would imagine that's so that you can have some better degree of control and get as close as possible to the line without making it a 1-point shot. Now, your mechanism for picking up the ball, are you going to be going after any particular ball, or are you going to go to whatever is closest to you? Okay. So you guys are going to be making these 2-point shots. You're going to be hoping that you can make more shots than they got that little closed circuit going with the ball in, ball out.
We're hoping it doesn't work out.
Hoping it doesn't work out, hoping that you can outscore them. Hopefully.
We're hoping they get lost along the way.
All right, that's a good plan. Now, you guys hopefully can, outscore them, do whatever. But I think it's going to be a good match. It doesn't seem like they're going to be interfering with each other too much, but it's going to be more of a contest of who can get the most amount of points with however you decided to approach the problem. That's a really good way to do it. Good luck to you guys. Yeah.